So Carl, K9LA, is going to talk about propagation of sunspots with us this evening. So everybody, welcome Carl, and thank you, Carl. You have the floor, sir.
Okay, thank you, Chuck. Well, good evening to all the Longmont Amateur Radio Club members. I'm Carl, K9LA, in Fort Wayne, Indiana. It's up in the northeast corner of the state, kind of close to Michigan and Ohio. We're almost at the western boundary of the Eastern time zone, but we're still on Eastern time, so it's 9:30 here. That's interesting when I give presentations to clubs on the West Coast. It gets kind of late here, but that's okay. Let me share my screen. Let's see here. More. We're capturing share. There we go. Okay.
You still have rights, right, Carl? Okay, good. Want to make sure.
There we go. Let me get it full screen here.
Yeah, I think that's on his.
I hope.
There we are. Now we can see it.
I don't see it yet.
Well, we see your slide presentation. Here's the first one, anyways. The presenter mode.
Oh, shoot. Okay. Okay. Well, I'll go with this, although it doesn't look right here. So this is an update on cycle 25 and also some more. Oops. There we go. And the last time I gave a presentation to your club was in May 2023. And back then talked about a variety of subjects, 1, 2, 3, 4, 5, 6, 7 of them. And it included at the end where cycle 25 was. And there's the chart from back in May 2023. The thick red line is cycle 25, and the green, orange, and blue are 3 other solar cycles. But back then we had 33 months of data since solar minimum. So it's a year and a half later. So we're going to have about a year and a half more data. So let's first talk about what we're going to cover. It's mostly from the Boulder amateur radio presentation that I gave in August 2024. We'll talk about cycle 25, some general knowledge topics about solar and propagation topics. A couple slides on the interesting events in early May of this year. Guidelines for the next several years, and then a quick summary. So let's start off with cycle 25, and we're going to start off with some history. I probably gave this back in May of 2023, but it's always good to look at it. It's a plot of the maximum smooth sunspot number of each of the previous 24 solar cycles. Cycle 1 began in 1755. I don't think any of us were around then. I'm pretty sure about that. You're probably familiar with the Maunder minimum. It occurred from 1645 to 1715 with few sunspots. Now, if you look through look at the graph, you see it's kind of cyclic in nature. Goes, just draw a line from the peak of each cycle, and it goes up, goes down, goes up, goes down, goes up. And it looks like it's going down. So what that says is we've been through 3 periods of big solar cycles. You can see cycles 1, 2, 3, and 4 were kind of big. Cycles 8 through 11 were big. And cycles, let's say 17 through 23 were kind of big. Now, what that also says is we've been through 2 periods of small solar cycles. For example, cycles 5, 6, and 7A were pretty small. In fact, cycle 6 is the smallest in recorded history. The next period of small solar cycles was 12, 13, 14, 15, and 16. They were a little bit bigger than that first solar minimum, but not too much. And then there's cycle 24, the last cycle, which was quite small. It was the smallest in our lifetimes. That's kind of easy to see. Probably the earliest solar cycle that in our lifetimes was cycle 19. It was the largest in recorded history. And just think if our HF rigs back during cycle 19 had 6 meters like they do today, boy, that would have been a heck of a lot of fun. I've also highlighted a moderately big cycle, cycle 21. It peaked in 1979. And then if you average all 24 cycles, cycle 23 was pretty close to the average. So cycle 23 was pretty much an average cycle. And of course, cycle 24 was a small one. And that's the big question about cycle 25. Is it going to keep us in a small period, or will it get us out of a small period? Now, here's the latest data. Again, the thick red line is cycle 25, how it's doing. You can see we have 52 months of data now. So that's pretty good. We got lots of data on this solar cycle. Also on the plot are 4 other solar cycles this time. The green is cycle 24. You can see it's kind of small. Now the X at the end of the curve is the signifies the maximum smooth sunspot number. So we've certainly exceeded cycle 24. Now the orange is that cycle 25, which is an average cycle. Its peak was about 179 or so. You can see that by the X at the end of the curve. That's where the maximum was for cycle 23. And we're going to make it up to a cycle 23. We shall see, and keep your fingers crossed, because the higher the sunspot cycle, the better the 15, 12, and 10 meter bands are, and also 6 meters. One thing, if you can see, there's bigger cycles rise faster. That's pretty obvious. There's that blue cycle 21, which was moderately big. And also cycle 19, the largest in recorded history. It really rose quite fast. And in general, the bigger cycles start higher at solar minimum. You can see cycle 25 started pretty low. Interestingly, cycle 19, the biggest in recorded history, wasn't too far away from that, but that cycle 21 started at about a smooth sunspot number of 20. So things are kind of variable, and we can't really predict a solar cycle by where it starts. So we just have to wait a while until we get more data. Now, is cycle 25 going to have 1 peak or 2 peaks? Now, there's 2 XL plots there. One is the one on the left is the monthly mean sunspot number per solar hemisphere. In other words, the blue curve tells us how many sunspots emerged during cycle 24 in the northern solar hemisphere. You can see initially when cycle 24 started, the northern hemisphere was more active than the southern hemisphere in orange, but as cycle 24 progressed, that switched. So towards the end of solar maximum of cycle 24, the southern solar hemisphere was contributing the most sunspots, and the northern solar hemisphere kind of wasn't doing too much. Now, you can see what that obviously probably is going to do is give us 2 peaks. And if you look on the right, that plot is the smooth sunspot number. In other words, it just takes all that data on the left and averages it even more to get rid of all the spikes. And you can see that the northern solar hemisphere was active initially, and then the southern solar hemisphere took over, and it gave us 2 peaks. And you can see the 2 peaks in the green dotted, which adds both the southern and the northern solar hemispheres. Cycle 25, if you look at the monthly mean numbers, up until several months ago, both solar hemispheres were kind of in concert. They were working together. But the past few months, the southern solar hemisphere has really taken off. And if you look at the smooth numbers, it doesn't really tell us that, because all those spikes are averaged out. And it says that the two solar hemispheres aren't too far apart, but if you look at the monthly means, it's quite obvious. So are we going to see one peak or two peak? I don't know. I think we're just going to have to wait to see what the sun does. Now, I talked about monthly mean sunspot numbers and smooth numbers. So what is monthly mean, what's daily, and what's smooth? Well, here's cycle 23 in terms of three measurements. The red is the daily sunspot number. You can see it's very spiky. So it's kind of hard to tell what a solar cycle is doing. So the obvious thing to do is, well, let's take every day of the month, the measurements, the daily measurements, and average them and get a monthly mean or a monthly average. And that's what the blue is, the blue curve. You could see it's still kind of spiky, but it's starting to show the true trend of the sunspot cycle. So if we average even further, if we take a 12-month running average of monthly means, that's a lot of averaging. You can see that it smooths out the whole curve, and that's the green curve. It's pretty obvious that cycle 23 also had two peaks. And I should point out that you can do the same thing with 10.7 centimeter solar flux, and you'll see the same trend. Daily values are very spiky. Monthly means are a bit better, and the smooth really does do what its name implies, smoothed. Now, we use smooth sunspot numbers for two reasons. One, it's the best way to see what a cycle is doing, as in the green curve, and it's the official measure of a solar cycle. The other important reason is the smooth sunspot number gives us the best correlation with what the ionosphere is doing. We don't have daily predictions. That's a tough one to handle. If today's solar flux is 100 and tomorrow's is 120, it doesn't mean tomorrow's going to have any. It doesn't mean the ionosphere is going to be better. It could be worse. And the worldwide ionosphere is not, of course, the same all over the world. There's ups and downs all over the world. Okay, what about the coming years? Turns out cycle 25 had a pretty similar rise to cycle 16. So in blue is cycle 16, in orange is cycle 25. You can see we've exceeded cycle 16, of course. I think what we're going to see for the rest of cycle 25 is kind of ups and downs like we see here in the blue curve for cycle 16. For 10-meter propagation on a consistent day-to-day basis, the smooth sunspot number has to be above about 100. And that's what that green line signifies. So it kind of says we should have good propagation on 15, 12, and 10 meters all the way out till 2027. Okay. Now, 15 and 12 are going to last a little longer because they don't require as high of a smooth sunspot number. And that's, of course, what opens 10 meters, lots of sunspots, more than 12 meters and more than 15 meters. Now, there's an interesting question. Did cycle 16 have 4 peaks? I've never seen a definition of what a peak is. How deep is the valley in between the peak? But I would kind of say that cycle 16 only had 1 peak. There was not a definite peak and then a definite minimum and then a definite peak again. So, kind of doesn't matter really. We'll just have to wait and see what cycle 25 does. Here's some general knowledge. There's a typical solar cycle in blue. A to B is the rise time. That's an average of about 4 years. B to C is the average decline time. It's about 7 years. So that's where the average duration of a solar cycle comes in at about 11 years. Some are shorter, some are longer. That's just an average. And there are other cycles in solar cycles. What we're looking at is the is the 11-year cycle, the Schwab cycle. And at solar maximum, the sun's magnetic field flips. So really it takes 2 cycles to get back to the original condition. And that's called a Hale cycle. It's 22 years. And the Gleisberg cycle, remember that plot of all previous solar cycles? Well, the period in between the peaks of the high solar periods, or the peak, or the duration between the peaks of the high periods and or the duration of the peaks of the low periods, about 88 to 90 years. That's called Gleisberg. All these names are associated with the guys who kind of observed hey, this is what's really happening. There's some longer cycles. Mostly, well, most of that comes from not sunspots, but looking at like carbon-14 in tree rings or beryllium-10 in ice core, because we just don't have good sunspot data back, more than or before 1755. Although I think the Chinese were measuring solar cycles almost 2,000 years ago. At least they were noting the spots, but there's not enough good data that allows us to really put together what was going on back then. Why I presented this mostly was to show when are solar flares and coronal mass ejections most prevalent around solar maximum. We'll get into that in a little bit. And coronal holes are most prevalent on the declining side of a solar cycle. So I'll mention this later, but we're pretty much at solar maximum for cycle 25. So we have to put up with solar flares and CMEs that cause disturbances to propagation. But the good part is, of course, there's lots of ionization to keep 10 meters open, and even 6 meters too. Unfortunately, coronal holes are worse than CMEs, so we'll still have some problems on the decline of cycle 25. You've probably heard of the K and A indices. The K index it's a logarithmic 3-hour index. It's reported every 3 hours. It's the maximum deviation of the Earth's magnetic field in the 8 3-hour periods throughout a day. And K goes from 0, a quiet magnetic field, to 9, extremely disturbed magnetic field. Remember, it's logarithmic, so it's a pretty compressed scale. The A index is the linear daily index. It's the average of the 8 K indices. So the K index is kind of a current measurement in a 3-hour period. The A index is what happened yesterday. The A index goes from 0, quiet magnetic field, to 400, extremely disturbed. And there's a little chart that you can convert from the K index to the equivalent linear index of the K field, which is little a. Now, when the K and A indices are high, that means the ionization in the F2 region can be significantly reduced. Generally, when the K index is less than or equal to 3, which is an A index less than 15, that means the F2 region is considered to be undisturbed and all is well. So why are sunspots important? Well, it's not the sunspots, it's really those white areas around sunspots, because those white areas, they're the areas that emit extreme ultraviolet, which is the true ionizing radiation of the F2 region. Those white areas are called plage, which is French for beach. And sunspots really don't ionize anything, nor does 10.7 centimeter solar flux. Both of those are just proxies for extreme ultraviolet, at least for the F2 region. And of course, the F2 region is responsible for most of our long distance QSOs and most QSOs at night, because the F2 region has the highest ionization level of all three of the regions, D, E, and F. And the F2 region is the highest also, which gives us the longest hops. So the F2 region is really important. And thankfully, it does not totally disappear at night. It still gives us nighttime propagation on the lower bands. Here's something interesting. The maximum usable frequency over a path, MUF, versus month in the Northern Hemisphere. This is a plot of the MUF for all 12 months from K9LA to England at 1500 UTC for 3 different levels of a solar cycle. And what's obvious is during the summer months in the Northern Hemisphere, the MUFs are the lowest. Okay. That certainly doesn't help the IARU contest in July, field day in June, and lots of state QSO parties. And you can see that the highest daytime MUFs are in the fall and winter months, and that's because of a change in the composition of the atmosphere that really is helpful for the F2 region in the fall and winter months. Of course, sporadic E helps in the summer if it occurs. Last summer, we did not have a very good sporadic E season. We just don't fully understand everything about sporadic E, so we can't say why not. There's still apparently some variables that we're not taking into account. Lots of research going on by a couple of amateurs too, and they're finding out some pretty interesting stuff that the lower atmosphere, events in the lower atmosphere, like the jet stream and thunderstorm activity, stuff like that, can looks like it may be triggering sporadic E, but we're gonna have to wait and see where all that research goes. So just be aware that we're entering the fall and winter months when the higher bands, set 15, 12, and 10 are going to be really good. In fact, they're really good right now. And the gentleman that talked about his fan dipole in the HOA area, yeah, I'm sure he's going to have a lot of fun on 15, 12, and 10 meters. Maybe even 6, more than just the XE worked. Also, we should be aware of short-term enhancements. So when the K index spikes up moderately, not remember the K index go up to 9. I'm not talking if it goes up to 9, just up to 5 or 6. That's a good time to look and check the higher HF bands, 15, 12, and 10, and also 6 meters. And here's an example on March 24th of this year. On Sunday, the K index spiked up on the 24th. And you can see in the plot of the Wallops Island ionosonde that on the 24th, the MUF over the ionosonde was took a nice increase up to about 46 megahertz, whereas normally it was down around 40 or 35 to 40. So just be aware that a moderate spike in the K index can really help the higher bands. Okay, talked about sunspot cycles. Well, in the mid-1990s, 1990s, there was some concern that the accuracy of the sunspot record wasn't maybe good enough. So 4 workshops were held to review the old data. And the end result of these workshops generated a new sunspot record that is considered to be more accurate than the old one. V1 is the old version, V2 is the new version. The biggest issue was when Adolf Wolfer took over from Rudolf Wolf in 1876. Adolf Wolfer had to multiply his count by 0.6 to agree with Wolf. So you can see there's some human bias in here. And of course, sunspots are subjective. You have to measure them. You have to count, how big is a sunspot before you count it? How long does a sunspot have to last before you count it? So it's kind of, like I said, it's subjective. After much analysis, that 0.6 factor was backed out. And what that does is makes the new record V2 values higher than the V1 values. And there's a plot of cycles 19 through 24 with blue in the old data and red in the blue in the old data and red in the new data. You can see that things are different. And the biggest thing to note here is that our propagation predictions were based on the V1 sunspot numbers. So if you plug in a current sunspot number without multiplying it times 0.6 to get back to the old numbers, you'll have probably one band optimistic predictions. It'll tell you 15 is open, but maybe not. Maybe only 17 is open. So just kind of understand that if you ever play around with VOACAP or W6EL prop. And also here's a picture of the worldwide ionosphere. And what it shows is the red lines are critical frequencies, the F2 region. That's related to the amount of ionization. And the equatorial ionosphere is the most robust area of the ionosphere. And as you move north or south from the equatorial region, the MUS go down. And if you can read those numbers, probably not, you'll note that me here in Fort Wayne, I'm at a disadvantage to those in the southern states because they have higher MUFs. And that's just the way it goes. You guys in Baltimore or not Baltimore, in the Boulder area also suffer a bit. Not as much as I do up in Fort Wayne, but that's the way it goes. Just realize, that like I've seen many times that the guys down in the southern states are working stuff I can't even hear on the higher bands. And that's because they're just closer to the equatorial ionosphere where the ionization is greater. And of course, take advantage of the digital modes. And here's just a little chart of the weak signal to noise ratio limits for the different modes. This comes from the WSJTX documentation. And you can see there that FT8 can detect signals with a minus 21 dB signal to noise, but you got to watch it. The bandwidth referenced is 2500 hertz. Now, these digital modes use narrow filters to decode the signal. So when you use a narrower bandwidth, that means there's less noise coming into your receiver, into your detector, which means you can detect weaker signals. So it's not that the digital modes can hear farther down in the noise. It's they reduce the noise so they can generally hear the signal better. And it's usually a weaker signal. You can see why Whisper is so popular. It can hear very weak signals because it uses a very narrow bandwidth to decode the signals. As you go down in that chart, the longer it takes to make a QSO. That's the way it goes. Okay, in early May, we had some really interesting things happen, and there's a good cartoon about that. Yeah, that's a good comment there in the right panel. I don't like the looks of this. The sun is not very, looks like it's a mean sun. And what happened in early May is it started with two really big sunspot areas, active region 3663 and active region 3664. Many solar flares from both regions. There were several coronal mass ejections from active region 3664. And this resulted in all three categories of disturbances to propagation. Those three categories are radio blackout due to a big solar flare, signals go away, mostly on the lower bands. A radio blackout offers the least impact of the three disturbances. A solar radiation storm is when a big solar flare and a CME are kind of concurrent. That affects paths across the polar caps. Now, that one's not too important because a lot of most of our QSOs aren't across the polar caps. You know, like from you or me, a path over the polar cap would be into like India or deep Russia. Geomagnetic storm, that's due to a CME, a coronal mass ejection. It can degrade the F2 region. And this is generally the worst of all three of the disturbances because it can last for several days. A radio blackout lasts maybe an hour and the bands recover. A solar radiation storm can last for a couple days, but a geomagnetic storm can last more than a couple days. And here's the data that showed up at the Space Weather Prediction Center. On the left is the X-ray flux, and you can see all those peaks are solar flares. And they cause the radio blackout on the sunlit side of the Earth. And like I said, they're of a short duration, about an hour, and the bands will recover with the most effect down in the lower bands. And on in the middle is the proton flux. That's where big solar flares concurrent with a CME can accelerate protons in the solar atmosphere, and they funnel into the polar cap, and they cause a solar radiation storm. Can last a day or two. On the right is the most interesting plot. That's the K index over the May 10th through May 12th time frame. I've never seen the K index be so high for almost 2 days. You can see it hit 9.3 in 3 of the 3 hour periods. It was at 8 and 7 a lot, and 6 even. So that caused the CMEs caused these elevated K indices. They caused geomagnetic storms, and they degraded the F2 region. In fact, the F2 region was degraded to about a half of what it normally would be without any disturbances. And it was quite obvious listening to the bands that was happening. And again, we have to remember that those disturbances are the bad. They occur mostly at solar maximum. Solar maximum is good for propagation on the higher bands because it produces lots of ionization for 15, 12, and 10. So we got to take the bad with the good. Okay, next several years, what's going to happen? Well, what allows a successful QSO? Well, that depends on 2 things, D region absorption and F2 region ionization. The D region absorption has to be low enough that we can hear or detect the signal, and the F2 region ionization needs to be high enough to refract the signal back to Earth, especially on the higher bands. 160 and 80, D region absorption is critical. The amount of F2 region ionization is usually high enough, and these 2 bands are best around solar minimum at night. Summer thunderstorms don't help, and that's why lots of top band people have low noise receive antennas. Always keep an eye on sunrise and sunset at your QTH and at the desired target QTH. There's a general consensus that 160 isn't as good as it used to be. I think there's something going on that we just don't fully understand, whether it's climate change, all the CO2 up there, or something else, more noise because we're getting more and more electronic devices around us now. It just seems to be tougher. And that's where FT8 certainly helps on 160 and 80. 15, 12, 10, and 6, well, there, the amount of ionization is critical. We need lots of sunspots. And the D region absorption is minimal. Those bands are best around solar maximum in the fall and winter months. And just remember that there are lower daytime MUFs during the summer months. And of course, sporadic E can help the summer months if it occurs. 40, 30, 20, 17 are transition bands. These bands are transitioning from D region absorption being critical to the amount of F2 region ionization being critical. So as a result, they're generally good over a solar cycle, 40, 30 in the nighttime, 20, 17 in the daytime. So just some general ideas. So here's the summary. Will cycle 25 get up to an average cycle? In my humble opinion, I don't think it will. I think it's going to be a smallish cycle, which kind of suggests maybe cycle 26 could be a small one. We'll see. Like I've said a couple of times, we have to take the good, lots of sunspots, with the bad, disturbances to propagation. The digital modes offer an advantage. And of course, that means more modest stations can have a lot of fun, like 100 watts to a dipole. So take advantage of it. Take advantage of the summer ES season if it occurs on 10 and 6. And get on 15, 12, and 10 right now because they are really good. They're going to get better as we move farther into the fall and then into the winter. And again, we're going to see this for a couple more years. So take advantage of it before we hit solar minimum again at around 2030. And there are tools on the internet to determine what the bands are doing right now. Like dxmaps.com, I like to use that one. You can pick a band and a world view, whether you just want to look at North America or the whole world. It shows who's working who in real time. So that pretty much tells you, if you take a look at that dxmaps.com, it'll tell you if it's worth turning the band switch to 10 meters or 6 meters. There's also PSK Reporter, WhisperNet, the Reverse Beacon Network, etc. So lots of ways to tell what's going on right now. Of course, in years past, we had to actually get on the bands and listen. And now we don't have to do that too much. So I guess that's progress. So that's all I had, Chuck. I'm going to send a PDF of this to your club probably tomorrow. And if there are any questions, I can sure try and answer them.
Great. Thanks, Carl. Anybody any questions online in the room?
I have a question.
Go ahead.
Carl, I've been doing pretty well with this little 100-watt transceiver and a simple dipole antenna. I'm up to 92 countries now. But the vast majority of my contacts, and I've been using almost exclusively FT8, some single sideband, but mostly FT8.
Okay.
But the vast majority of my contacts, I see, I have a very large difference between the receive and transmit signal to noise ratios that are recorded.
Mm-hmm.
And I was wondering, is there some asymmetry in the ionosphere that results in the paths not being equal attenuation in both directions?
Yeah, that's a question that's been asked quite a bit, and people wonder about it. Before you start looking at the ionosphere, you should try and understand what's your noise level, what's the noise level over on the other side of your contact. And you rightfully said that what it measures is the signal to noise ratio. So the noise has a big impact. Also, it's measuring the noise from other signals too. So depending on how crowded the band is, that could reduce your signal to noise ratio too. So there's some
Signal to
variables
signal
that I
plus
don't think,
noise.
yeah, I don't think we understand enough, but I certainly agree with you that the ionosphere can give us asymmetrical propagation. And that's because the ionosphere is immersed in the Earth's magnetic field, and that really has a big impact on what's going on. It can affect propagation depending on which way the propagation is going. So I've never seen anything dig really, really, really deep into that, but it seems that probably there could be an explanation in there. But don't count out the other stuff either, and how much power you're running, how much power the other station's running.
Well, the antennas are going to be the same
too.
whether transmit and receive on both ends. And if the other guys are not running more than 1,000 watts, then
Yep.
it shouldn't be more than about a 10 dB difference on average. But I see a much bigger difference
Yep.
most of the time.
Yeah,
A lot of times, my receive signal level that I receive is as much as 30 dB higher than the report I get back.
Yep. Yeah, that's yeah. You know what else is frustrating, Mike? Listening on the FT8 frequencies on 6 meters and hearing signals, the FT8 signals, but nobody's on CW or sideband. And if you can hear the FT8 signals with your ears, sideband and CW should be going too. But I guess everybody's just on FT8. That's how I guess that's how our amateur service is evolving, it looks like.
Yeah, there's not much on sideband.
Nope.
I got I don't know, maybe 100 QSOs on sideband when I first plugged in this radio a couple of years ago.
Yep.
But every time I go back and listen now, there's hardly anything going on other than a few nits.
There was just a couple days ago on the Front Range 6 meter group, the reflector. I think it's N0YK worked CE6 down in Chile. And there were some other stations working, I think, into JA and Asia on 6 meters. So you got to be in the right place at the right time, unfortunately.
Yeah, I did hear one European station on set. I wasn't able to, contact him. Anyway, it was very exciting for me. 50 years and first time I made any contacts on 6 meters.
Yeah. I think, like I said, this summer wasn't very good for sporadic E. I think the previous summer was. It'd be certainly nice to understand what's going on. But
hopefully it'll be good next year for field day.
There you go.
That's all we can hope for. The past is the past. Now we can look at the present and the future.
Yep, that's right.
Field day is within the U.S. almost all. So
A lot of times, yeah.
I mean, a lot of this is talking about international
Right.
context, and there's darn little of that in the field day.
So, anybody have any other questions?
I guess I've got a comment. This is K2AD. I went back to the old group that I used to operate VHF contests from in Massachusetts and spent a lot of time on 6 meters in June and September. And you're right, the bands will be open. No one is on sideband CW. We at one point started seeing a little bit of stuff, and we aimed the antennas to Europe from Western Massachusetts and worked about 50 stations on CW. And then they were all worked out and nobody else would answer. So we put our antennas to the south and to the west, and we were using PSK Reporter, the mapping software, and it was reporting back to us that there were hundreds of stations hearing us, but no one answering the CQs. And apparently there's an awful lot of stations out there automatically reporting and decoding unattended, and the band will be open and there's nobody to work.
Yep.
But I guess the point of this is to the guys that have the small stations, and we were running 4 stacked Yagis and legal limits, so it was a bigger station. But if you have a small station, look at these maps. You've now got some info here from this talk to kind of give you a feel for what might be open, and point your antenna there and see what comes back. And we were listening, and we saw all of a sudden, gee, we're being heard in Brazil and Peru. We put the antennas down there and worked, I don't know, 3-4 stations on transequatorial, and then it was gone, and you had to move your antenna. And so you can work a lot of people on these digital modes. You've just got to have an understanding of the sunspot cycle, an understanding of the propagation, use these maps, and you'll be amazed at what you can work. But yes, I wish more people would spin that dial down to 50.130 or get on sideband and CW on the HF bands, and we could have a real QSO.
Yeah. Thanks, Doug. Also, I'll mention that if you look at where sporadic E occurs in the world, there seems to be a very good area in the North Atlantic, which you would think that favors the East Coast to Europe. And I think that does happen. Unfortunately, it's not good enough for the Midwest, and the West Coast isn't good either, but that's the way it is. And
if you're in Colorado, you're not going to get to Europe easily.
Yep.
At least on 6 meters.
Yep.
Any other questions?
You're kind of getting the auroral oval is kind of might be getting in the way for some of your European contacts too. So that's another thing that doesn't help. But oh well. That's what makes ham radio fun, right? It's not predictable.
You're right.
Darn.
You're absolutely right that 10 and 12 and 15 are really exciting. And I was snoozing for last few months, and somebody alerted me to get on 10, and all of a sudden, well, a year ago, 10 was a total wasteland, and now it's pretty cool. But it's a daytime band mostly. I mean, you're a little bit after sunset, but that would be lucky. So people with regular jobs.
Yeah, when it's hot,
fun.
When it's hot, it's really hot.
It's cold, it's freezing.
Yeah, exactly.
Yep.
I mean, I've heard activity at 10 well into the 8, 9 at night. Not always, but sometimes. So there's something that makes it hang on a little longer.
Okay. Any other questions, comments?
Yeah, I'm wondering if you could recommend any good books or learning resources to understand this better.
Sure. Well, the ARRL antenna book, the ARRL handbook, they both have chapters on propagation and solar stuff. And in fact, those 2 chapters were kind of put together into a book. Here to there, ARRL publishes. If you go to the ARRL bookstore, you'll find it. There's also Bob Brown, NM7M. He's a silent key. He wrote a book, The Little Pistol's Guide to Propagation. It's out of print, but it's on my website. When I send you the PDF, my website is K9LA or K9LA.us. So that's pretty simple to remember. But you'll find his book there. You can download it. It's about a 5 meg file, I think. But his book is kind of in between the heavily technical and the very light. So he'll give you lots of good information. I tell you what, I'll add another slide at the end with references, okay? And, that'll be a better way for you to go after them, yeah.
Great, thanks.
Yep.
Great. Thank you. Anybody else? Not saying anything. Carl, thank you again.
You're welcome.
Laid out there for you, but
No, not too bad. Our cat, we have an adult male cat, and then about a year and a half ago, we adopted a litter of 7 kitties. So we got 8 cats running around, and you probably saw one of the tails go by on the screen. They like to walk across the desk. I got to make sure they don't step on a keyboard, of course,
yeah.
in the meeting. But
Cats love to sleep on keyboards.
yeah, or warm amps. Yep.
Yep. All right. Well, again, thank you very much.
Yeah.
Okay.
Appreciate it. Great evening.
Thank you. Okay.
I'll post the PDF on the website for people to download if you'd like. Just let me know and we'll get it out there. So, everybody, thank you very much for attending this evening.
Hey, Chuck,
Yes.
one pitch, you were asking for people to contribute. I'm a member of LARC, and I saw that Carl made a presentation to them a couple months ago and reached out to him and got him to agree to do this tonight. So everybody pay attention to what's going on elsewhere. And because right now Chuck has got the responsibility for trying to bring in programs, and that shouldn't be on his shoulders. It ought to be on everybody's.
Thank you, Bob.
And he's always happy to jump on something and help work it out. But people need to make suggestions and track things down for him.
Yes. If you know somebody, let's get them on. So, actually, after the first year, Doug, I think we need an arm ham presentation. Hit, nudge, nudge.
Presentation on what?
Arm ham. Market yourself.
That's pretty.
You need some spares, don't you?
You don't want to hear about the group. What we need to find is something interesting that we're doing.
No, we'll have all kinds of interesting topics, I think.
You broke up a little bit. What do you think would be an interesting topic?
No, I know you guys have all kinds of interesting topics as well. I know you do the ARM university and things like that. So maybe a small presentation on something from that might be good for the club.
Yeah, we could certainly do something along those lines. And speaking of which, the first RM Ham University is going to be this coming Saturday, and it's on DMR programming. If you have a non-Motorola, non-commercial radio. So this is the, I don't even know the brands because I have Kenwood and Motorola, but the Anytones and these other radios and how to program them and TYTs. And you can either go to this in person at Cherry Creek Schools, or you can pick it up online through Zoom. There is no charge, and we'd love to have people attend. So you can, if you're interested in that, register at rmham.org at the university tab. And I think after this one, trying to remember, this is October, what November is, but December is a few of us doing solar projects, solar panels, chargers, components.
So
and
coming up on fox hunting, that should be near and dear to this club,
I think it's in November, isn't it?
Maybe it is November.
is fox hunting in November? I think there is one on that.
To get beyond the
And-
basics and get into the more sophisticated stuff.
Yeah.
$15 or something, you put your DeWalt battery in there. This is a regulator. It's both a boost to low voltage or flip a high voltage so that you reliably get 13.8 out of this thing. So, batteries you already own, maybe. And I don't know if there's Milwaukee or somebody else that sells the equivalent of this thing, but there's an 8 amp hour emergency power for whatever you're doing, or something you already own. This is what we think about. And finally, those of you who have bought Baofengs over the years and, collected Baofengs for $40 each or something and work. You know, the original set 3 or 4 years ago was a little flaky, but now they're pretty solid. Well, they're no longer alone. There's at least 2 competitors out there. You know, one is called TID Radio. The people up in northern Colorado got all excited about this thing. A few people bought it for $35 a copy and played with it and concluded that it worked. And so now they're buying lots of them. Lots of people up there are buying lots of them for $35 a pop or 2 for $70. And it works. That wasn't enough. There's now what I won at the Ham Fest was called Talk Pod. There was a Talk Pod. And this thing, they claim it's 8 watts, you know, and I think the average ball fan is 3 watts or something. I'm not sure I could prove that it's 8 watts, but that's what they claim. It's a little bigger than a ball fan. And these things have added features, you know, this thing can also operate on GMRS and receive aircraft signals and a few other whiz-bang things. So they, you know, the war is on among the cheap Chinese radios, and there's 2 new entries. And I can tell you they both work.
I know mine was. About the car, I use it. But yeah, anything else? Anybody else got anything they can bring up? Something they've done or complicated?
I have one.
Go ahead.
Shows my age. Barry Goldwater was the senator from Arizona, and I was able to work him twice, and that was probably 50 years ago or so. One time I knew who he was. The other time I was just working him, and I didn't really have his call sign memorized. And I said, "Well, where do you live?" And he says, "I live near Washington, D.C." And I said, "Well, what do you do for a living?" And I was kind of thinking it might be him. He said, "Well, I work for the government." And he finally admitted it was Barry Goldwater. So that was a very exciting contact for me.
I have something to add to that. Sometime back in the 60s, early 60s, I think, I talked to Barry Goldwater, Aeronautical Mobile. He was in a beach or something down in somewhere in the South, and talked to him, Aeronautical Mobile.
So there's one more thing to add on. There's a club in the Phoenix area. It was a Arizona QSO party a week ago or so. Somehow or another, they got Barry Goldwater's call sign at K7UGA, and it's now the club's call sign. So I was looking at the computer, and there's K7UGA. He's been dead for 30 years.
He's still making contact.
Yeah, but he's a politician, and they never die.
You look at the QSL card for this club, and it's got Barry's picture.
But keep his memory alive, that's good.
Very cool.
Yeah, he did a lot. You know, he was a technology kind of focused in his as a senator, so he did a lot of good. And when I lived in Phoenix, I would drive past his house. He was up on the top of Camelback Mountain with this big log periodic, and he let the local clubs use it for running phone patch traffic for servicemen in Vietnam. So he kept his station very busy. But anyhow, I'm gonna get Barry's card,
Good for you.
at least the card with Barry's picture.
That's great. Anybody got anything else to bring up?
I'd like to see, yeah, so, a couple weekends ago, it wasn't this past Saturday, but Saturday before, I actually, activated St. Vrain State Park as POTA, and thanks to you and who was the one to Pawnee Grasslands with us, Mike?
Mike?
Yeah, so that was my first experience. I didn't know what to do, how to do it, because I went to that event. I was able to go and I actually activated Jackson Lake State Park and now St. Vrain on my own. And the cool thing about that, especially when you go to these highly populated areas, is people come up and ask you what you're doing. And so you get to explain what ham radio is, or some of them already know what it is, and they're just reminiscing about, oh yeah, my grandpa or my dad did it, and all that. But it's also fun. I asked them first, they asked me what I'm doing. And before I answer, I always ask them, what do you think I'm doing? And I love to hear all the different answers that I get. So
Sometimes there's some crazy ones too.
oh yeah. My neighbor asked me if I'm contacting the mothership, so
I tell them yes.
yeah.
What'd you say?
Yeah, well, that's exactly.
I tell them yes.
Yeah.
Somebody else on the call have something they want to bring up?
I got to see our.
I've got
books.
I have something to share when it's my,
All right, so let's see, I think Doug, you had something?
Yeah, but the other guys can go first if I can wait.
Well, go ahead.
I don't know if mine's as interesting.
Well, shoot.
Okay, well, I can throw it out here. And this is not as interesting as everybody actually getting on the air, which is way cool. But I've been working on the microwave backbone with Mark Skelton, Dave Mazurowski, and we were recently out at the Firestone hub trying to get some 60 gigahertz running from there over to my new property up here north of Longmont. That way we can add some club receivers and even transmitters as we need. And it doesn't work, as it turns out. There's a tree in the way, and at 60 gigahertz, this tree is probably half a mile from one of the two sites, and it's dead smack in the middle of the path. So we're going to be doing a little more work, and I guess you don't have screen sharing turned on, but I have a cool picture of Mark up on the tower. But
I can make you share really quick here. Hang on. There you go.
Okay.
You should be
Let
able to
me get that. You are now okay. I've got my little screen on here. So if we do that, and are you seeing the video now?
You see the picture.
Or the still photo? So that's and Zoom is putting windows over windows, so I can't zoom in, but there we go. So there's Mark up on the tower, and the 60 gig dish pointed back to Longmont. And this, I think, dish down here is pointed to Lee Hill. And this is what's going to carry our voting receiver traffic on our VHF and UHF. So and this Zoom thing keeps putting the window over top of what I'm trying to do. And there's the whole
where's that
photo.
Firestone hub?
That's at the Public Works facility. It's just about a 28-foot Roan 45 sunk into concrete, so it's freestanding. And we had a deal with the town of Firestone. We actually had to go to the Board of Trustees and get approval to put in a ham tower and put it on their property. That way we would have public service, and the microwave backbone goes through here. So there's Mark up on the top. So it's a fairly decent tower, 18-inch face, and various dish antennas in there. Mark put up this antenna that I gave him. That's just a 2-meter 440, and he's running one of the voting receivers on 2.7 on that. So that's one of the cool projects I've been working on, and I enjoyed the Barry Goldwater story. I kind of had a similar one that I was listening on the air and heard somebody calling CQ, and this guy came back. I think he was in Alabama, to the DX station, and the guy asked him, well, what do you do? And the DX station said, well, I'm in government. And it turned out to be his call sign was Juliet Yankee 1.
Yeah.
And that was King Hussein of Jordan. So I just liked the way he said, he's a king, and he goes, I'm in government. So yeah, you never know who you're going to meet on the radio. So
That's very true.
that's that's my fun project of the day.
Thank you, Doug.
That's awesome.
Jason, you had something you want to bring up?
I was gonna say I saw our Go box this weekend because I guess Trevor had it
Mm-hmm.
and he was doing the POTA at Sawtooth Ponds near my house with the University of Colorado Club. And so I got to see them make quite a bit of contacts. I think I left, they were close to 40.
Good.
And so it was awesome to see like these young college kids enjoying POTA.
There you go. See, we're trying to get the youngsters involved and
Yeah.
see who started a new radio club. So I am trying to work a partnership with them as well. So hopefully we'll get more of them involved with our club as well.
Yeah.
And Michael, you had something as well?
Yeah, I guess I would start by just, giving a little of my background since most people might not know me. I was a very active amateur radio operator back in my teen years and early 20s. And then life got in the way for about 40 years. And I just got back into the activity about 2 years ago. I bought an FT DX10 and put up a 20-meter dipole just hanging on the roof because I live in an HOA area that doesn't permit any real antennas. But in spite of that, I was able to get up to about 50 or 60 good DX contacts with a simple dipole and 100 watts. And more recently, I decided to try and get on more bands. And I did a little research and came up with the HOA special. It's a fan dipole. And if I can share that screen, I have a picture of it that I think would be interesting. It says it's disabled.
There you go.
There we go.
Careful what you ask for.
Yeah. So this is a fan dipole that has 40 meters on the top, then 20 meters, then 15, 10, and 6 meters. Behind the balun here is an ADS-B antenna and LNA that I use for tracking aircraft. I'm a pilot also, so I track aircraft with that. And so just a couple of days ago, for the first time, I made my first 6-meter QSO ever. I don't know how many thousands, tens of thousands of QSOs, but I'd never made a QSO on 10 meters. 6 meters until just a few days ago. And the first one was with somebody in Mexico, XC2JS, which really surprised me. I wasn't expecting a lot of DX on 6 meters, but I guess it's out there. And I have worked a couple of other contacts, but for me, that was a real thrill to be able to work another country on 6 meters.
All right. Excellent. Thank you. And I want to thank everybody who participated in this little exercise because this is something new the club's going to do. And thank a club member for this because it was their idea to kind of, get more involved and see what people are doing and things like that. So make note if you have a question on fan dipole. I'm sure Michael will be more than happy to help you out. Maybe figure stuff like that, or some other club member will as well. So thank you everybody who participated in that little thing. And I want to give you all a round of applause. And thank you because I think it's usually how we're trying to expand the club and do something different, right?
It's a great idea.
So thank you all for that. One other quick thing I forgot to mention, SOTA coming up in end of November, December. For those of you who don't know, that's Santa on the Air, not Summits, Santa. We've got multiple clubs involved this year with SOTA. There's ourselves, Northern Colorado Amateur Radio Club, and we have a club, the Alfred Memorial Radio Club out of Stone Mountain, Georgia. We'll be linking their Echolink with our Echolink to get more RF out into the world for kids to talk to Santa Claus this year. If you are interested and would like to be a Santa or an elf, please contact me. I'm still looking for Santas and elves. Or if you'd like to be a Mrs. Claus, we'd like to have you as well. We're doing a little bit different this year. We're only doing 1 hour each day. We're doing 2 hours on the weekends, but not consecutive hours. So there won't be as much dead air, things like that we've had in the past. And we have a lot more participation with Santas and stuff. So if you're interested, please let me know. I do have some slots that are still open, and I'm looking for people to fill those as well. We run it from the 29th of November, the day after Thanksgiving, until the 10th of December. I collect all of the information. Elf Chucky hand writes every QSL card for the kids with the contact information. We put them in envelopes, stamp them, address them, take it to the post office, and they get postmarked from North Pole, Alaska, and sent out to the children. So that's something different. That's something we've been doing for several years with the club, with the support of NCART, and now other clubs helping out as well. So please join us, and this is our 4th year. So I thank everybody who helps participate with that and helps keep that going. So appreciate it.